We're going to simplify a couple radical expressions that have different indices. And even if you're not especially comfortable with working with cube roots, fourth roots, and so on, changing these radicals to fractional exponents can often make the job a lot easier. So for the first example, we have the sixth root of x to the fifth. And we realize that the base is x, and it's got a fifth power inside. But that sixth root, that index, we can represent in fraction format, and so we make this 1 divided by 6. And so that's our first radical expression. And then the second one, which is multiplied, so the x cubed inside the radical we write as x cubed, but the fourth root we can write as that base to the 1/4 power. And now we're going to use our power to a power rule. So when we take an exponent to a power and raise it to a power, we will multiply those exponents. So we've got 5 divided by 1 times 1/6, and that's going to give us x to the 5/6 multiplied by the second exponent, and in this case we end up with x raised to the 3 times 1/4, which gives us 3/4. And finally, to simplify here, whenever you multiply bases, we will be adding the exponents. So we will take the base of x, and we're going to add those exponents of 5/6 to 3/4. And unfortunately, we have a least common denominator problem here, but we will figure out how to make that work. So 6 and 4 have a common denominator of 12. So we can think of that 6 in the denominator as being multiplied by 2, which means we'll multiply also by 2 in the numerator. And so that gives us x to the 10/12. And then we will add to that the second fraction, denominator of 4. To build it up to 12, we need to multiply both numerator and denominator by 3. So the second fraction is 9/12. And finally, putting that all together, we end up with x to the 19/12. Now we could leave that fraction this way, but the other thing that we could do is to convert that improper fraction to a mixed number, so it becomes x raised to the 1 7/12 power. And if we now separate this and make it x to the first times x to the 7/12, there are some who would prefer to write this expression as x times x to the 7/12, where the integer exponent, in this case first power, is separated from the factor that has the fractional exponent. Let's take a look at another example where we actually have nested radicals. And so I'm again going to change each of these roots into a fractional exponent, and I'm going to work from the inside to the outside. So this cube root on the outside will stay the same, but the x to the 9th on the inside has a fourth root on it, and so I'll make that a 1/4 power. Next, I want to use the power to a power rule inside of the radical, so I'll leave that cube root alone for a minute. But the exponent of 9 you can think of as being divided by 1, so this is going to look like x to the 9/4. And I could try to change this to a mixed number as I did before, but because I still have some work to do with this radical, I'm going to leave it as is. So now, again, we will change the cube root into a 1/3 power, and inside we still have x raised to the 9/4. But this time, when we've got these two exponents, power to a power, we will multiply the exponents, 9/4 times 1/3. And there's actually some canceling that will happen here. I can take out a factor of 3, and I'm left then with the 3/4 power. So in its most simplified form, this is going to look like x raised to the 3/4 power.